Okay, so in this video I'm going to be installing MX GNU Linux and then basically showing you how to recompile the kernel in order to make it run faster. So let's get started. Okay, so that's just the live CD part booting up. Right, so now I'm just gonna run the installer and just go through it. Alright, so I'm just gonna change the keyboard. Okay, so just change, so just gonna carry on, so format the whole disk. And so now while it's doing that, we can go through some operations. Because basically you can do these while the installer is running, but it'll get to a point where it will actually stop. If you don't complete these particular parts of the installation. Right, and actually they're not as difficult as the other distros where they complain if you use a rubbish password, which isn't so bad. Right, so that's it. So that's the configuration done. So we're just going to wait for the installation to finish. So I'll most likely just cut this part. So for when it gets to 100%. Alright, so now we just wait for it to reboot. Alright, just asked me to press the key, but yeah. And usually it's an interesting thing. So someone complained about when they ran an install that I watched on YouTube that the boot up was slow. Right, so now what we want to be doing is to get this compilation process on the road. So in order to do that, just gonna need to go into a browser. And what you can do is if you go to my website, and if you basically just click on, where is it? The application is used, it should be, oh no, that's not it. Yeah, I'll put it in, alright. Yes, if you go, well, media, it will show up in there. It might, when you watch this, it might not be at the top anymore. So basically just select there and you find like the instructions for what to do. So first thing you want to do is to go into a terminal. So click on the funny symbol and then just go to the terminal. Actually, let me just see if I can change the... So they make it difficult to change the resolution. Okay, so just what, change that just so it fits better onto the screen and gives me a bit more width. Right, so first thing we do is install these applications. You probably don't need all of them, but I just thought I might as well put them all in anyway. Alright, okay. I'll have to make sure to edit that. Okay, so now we just install these extra applications. You've got to make sure that's sudo first. Okay, so that's done. So now alright, so might as well just do this update as well. Right, so I just want to check something. Alright. Yeah, so now what we have to do is to edit the sources file for apt-get so that to enable the you have to enable the deb source so we can download the source for the kernel. And also, we need to enable this because there's one program, that's right, for the benchmarking that I need. So then you just save that and then Control X to exit. And so then just do update. Right, fine. So now for the kernel, we just need to get the dependencies for it. So that's quite a lot. So just let that download. Okay, so that's finished installing these dependencies. So now the next thing we need is to get the source for the kernel. And as you see here, you have to make sure not to do this as root. So you have to do this as a normal user. Because if you try it as root, there's an error that will come up right at the end. And I have to admit, I don't normally use sudo, but in this case, you have to do everything else as not as root. So it was actually easier doing it like how most people keep saying you're supposed to do it. Hello? Yeah, 294. Yeah. Alright, okay, bye. Right, so now that's downloaded the source for the kernel, and it's applied a load of patches from Debian, and that's the reason why I do it this way, so that, you know, if there'll be a few security patches in there, so it's best to get them added as well. So now if you do an ls, you'll see the actual what has been downloaded, and so now you just want to cd into the Linux, right, the form, whatever version it is, because obviously if you do this a bit later on, that version might have increased. So you cd in there, and then now we have to use good old fake root to actually do the configuration for the kernel. And so basically this is for obviously a 64-bit kernel, but since that's what pretty much everyone's running now, and if you're on a machine, you're doing this because you want to speed your machine up, then yeah, you're going to be a 64-bit person anyway, because 32-bit is just going to be slow, whatever you try and do. Anyway, 32-bit only is back in the days of, I think it's before Prescott actually. Right, so now we've configured it, and so now comes the important bit, where we want to do the menuconfig. So if you put this command in, and now this is where we do all the big stuff, because what we're having to do is to remove all of the debugging sort of stuff which has been put in. So we just got to go through. Right, so I'm just gonna. I didn't get this to work last time, so because what you're doing here is just so that to try and stop it from clashing with the distro kernel. Right, so you just need to go through now, and so for preemption, for best speed, we want a low latency desktop, and shouldn't have to change too much here. It's worth turning this on. It can come in handy for when you want the configuration. Right, so most of these particular ones, I don't. Yeah, now here's the first thing. So this one you have to turn off by pressing N, because if you don't, then you can't turn off certain debugging. Yeah, you can't turn off kernel debugging if you leave that on. So I don't think this makes any difference. Right, and yeah, so slub is good. harden, so I don't think we want that. And I'll get rid of so get rid of profiling support. And I think this is okay, because usually to work out which ones to remove, just read it and make sure yeah, see, this option makes minor performance sacrifices. So whenever you see performance sacrifice, just get rid of it. Because remember, we're being like Microsoft in the old days now, where you just don't care about security and only performance matters. Right, so that's everything from there. So now, next one you have to go into processor type and features. Now, here's the big one. You have to make sure to get rid of, so press N for avoid speculative indirect branches, because this sucks your kernel resources, so get rid of that. And I think that makes a lot of difference to the performance when you choose that. So I'm on a, yeah, I'm not, so what for this one, you just select a Core 2. Or if you're not an AMD, just choose the Opteron one. But so Core 2 just helps with certain things. Well, I'm not on AMD, and you don't need IBM. But yeah, you don't want NUMA, because that's when you got multiple processors. So no point wasting time with that. And I think it doesn't really matter about get rid of memory protection. Keep EFI in case you're booting from EFI. Yeah, so these ones, let's just check this one. Yeah, it's got no runtime impact, so you don't have to worry about that. So next thing, I think bus binary firmware. Oh, that's right. So you want to keep that on. So might as well get rid of that. And I don't think that makes much of a difference. Yeah, I don't think that's right. Yeah, see, at the expense of speed, so straight away it can be slightly slower. So no, so we get rid of that. Right, so there's no profiling. So anything that says at the expense of speed, you get rid of it immediately. And so now, I think most of these you don't. Now the other thing that helps, of course, is if you can make the kernel smaller. One way to do that is if you go into, where is it? Yeah, so device drivers, because this actually helps to reduce the compilation time as well. Yeah, don't worry about that. So we don't need GNSS, don't need MTD, shouldn't need parallel port. Don't get rid of that or your machine's dead. So now you can go into SCSI, and just to save the time it takes to compile, just go into, so your low-level drivers. Basically, if you're just using a normal drive and it says, and in your BIOS it says AHCI, then basically you can just get rid of all of this, and that saves a lot of compilation. Get rid of PMC, yeah, that, and yeah, we don't need any of that. We don't need, so all this stuff, this does actually save a lot of compilation time when you get rid of these. Okay, we don't need login. Right, so now the easiest thing to do here is to, And obviously if you do N here, then your machine is dead basically, it's not going to boot. So if you do yes here, and then just do yes for AHCI, that pretty much covers everything. Because like 99% of boards out there use AHCI for, 90%. The rest will use, NVMe if you got one of the fancy machines. So now for SFF, you shouldn't really need this either, so that helps reduce the compile time as well. And so as long as you've got this AHCI and the NVMe, so you might as well, you can see, yes, if you've got an NVMe, just build it in, but because this is a virtual machine, so I don't actually need that. So the other ones, yeah, get rid of this. The Firewire, we don't need that. And you might as well leave network device alone. And so we don't need SPI. We don't need one wire. Remote controller. Yeah, you don't need that. Now multimedia, that's for if you got like capture cards, etc. And you want to keep that on sound card, so you don't need this. Now it says SD card, but this isn't talking about an SD card slot. This is talking about special PCI hardware, which you find in some older laptops. So if you got an old laptop which has a PCI SD card, then you need this, but majority of new people nowadays don't. You definitely don't need Sony memory stick. And yeah, not InfiniBand, not that either. DMA you don't need. User space, no, forget that. And you only need this if you're actually, I need VirtIO because I'm running a VirtIO sort of block device. So might as well keep staging drivers. We don't need Microsoft. So you don't need Chrome either. Forget that. Don't need that. So all this basically saves. So, see what's good about this is if you remove all these options, the next time you compile the kernel, it's a lot quicker. So yeah, it takes a while the first time to going through all this and having to make sure all of this is deselected. But for the next time when you do a recompile, all these things you've turned off, it just means it's going to compile quicker. And so I'm just going to check one thing because I'm on a virtual machine. I just want to make sure. Oh yeah, you don't need a lot of these, so get rid of that. Yeah, you want your RAM disk, don't need this. That's Zen block, yeah, maybe. Alright, so VirtIO, so I need that because that's what I think it's complaining because the VirtIO is a module. So it can be a bit annoying this when you have to go back. Yeah, see, PCI needs to be built in because the VirtIO driver is actually a PCI device. So block devices. What else can we get rid of? Yes, we don't need. This is all old stuff. So null, you don't need that. You don't need a floppy. Yeah, this is old. This is if you're in a sort of cluster. NBD comes in handy though sometimes. So VirtIO, we can just make that yes now. And might as well use that ICSI pass through, so you don't need RAIDOS. And this is another old IBM. So I think that's it for devices. And if you can go through it a bit more, but the problem is you have to actually know what you're turning off. So now for the next big one is security options. So now, you basically turn off everything in here because all these options slow your kernel down. So so that gets rid of a lot. Now here's another one. This is the next killer. This is for fixing another sort of spectrum meltdown bug. So obviously it slows down your kernel as well. And turn that off. Right, so you notice so it says here security FS is enabled. So what you do is you notice you can't turn it off. So you have to check to see what has enabled it. And it seems it's a TPM. So if we want to disable this, we have to find where the TPM is. Let's see if we can find that. Well, actually, I think it's in miscellaneous, actually. I don't know why they call it miscellaneous. Yeah, there we go. Yes, we can get rid of them. It can get rid of all this. No one cares about these. That's why they call miscellaneous. Yeah, management engine, I mean. I don't know what this is. I'll get rid of that. Yeah, admittedly, most Intel chips do have the management engine to spy on you, so it just helps so that you can know that it's actually loaded, because the driver can talk to it. Right, and so you need a non-standard serial port. Who cares about that? So most of this is all server stuff. So yeah, that's an old one. Yeah, it's old. Alright, see TPM. So since we don't care about security, we'll get rid of that. So exit. So now if we go to security options, now we can get rid of security FS. So that's it. So we clean that out. So our speed is up quite a bit now. So you can't get rid of this because this is for encrypted file systems. So just in case, obviously encrypted file system is a good thing to have. So you've got to keep that. So now the next big one is the kernel hacking. So this is all lots of debug stuff to slow your machine down. So we're getting rid of everything here. So get rid of that. And so you notice when you look down and see there's a whole load of things turned on there. Well, not a whole load, but there's quite a few options there. So if you just turn off kernel debugging, that just cuts a load of things out. It's a bit shorter. So basically that, when I turned off expert before, if you don't turn off expert, then you can't turn this off. And so now let's just go through and so enable this one. Yeah, that's okay. So now memory. Yes, we turn that off. We don't want to poison anything. So now, see, nothing there. Right, see these two are forced on, so that means we need to find some other options which are turned on. So you turn off, yeah, see, when you turn off tracers, now you can turn off backtrace. So we get runtime. Test could come in handy. I think that's just at the beginning, so that shouldn't affect the performance. And yeah, might as well, we're getting rid of everything. So notice that the early print K, that's stuck on as well, so we have to do something to get rid of that. Right, now here's the next. So you notice, so we've gone through that, and you notice that there's two more things that we can't seem to handle. Oh yeah, another one we need to do is this IO delay. Just do no. Apparently if you've got an old machine, it causes a problem, but I don't know. I haven't seen that happen so far. So when you look at this unwinder, see, you've got two options. You've got the frame pointer unwinder, and notice it says here, it says that the overall performance will degrade by roughly 5 to 10%, so you don't want that. So now we've got the awk unwinder, and you'll think, so it enables a 5 to 10% improvement, but enabling this option will increase the kernel's runtime memory usage by roughly 2 to 4 megabytes. So our kernel is actually using more memory than usual, and you'd think that, okay, there's only two options here, so if I choose the top one, I'm okay. But no, there's some dodgy stuff going on with these kernel developers. So the basic problem we have is that for these two options here, this early print K and for this awk unwinder, to get rid of these to get our final bit of speed up, we have to do a bit of cheating. So now if we exit here, and we just exit from this, and then we save the configuration, so all that time doesn't go to waste. And now what we have to do is, now we come to these mysterious parts here, which you're probably wondering why they're there. So basically what you have to do is to just type MC for Midnight Commander. And so we're in the directory for the kernel. And so we have to go according to what it says here. You have to go to arch x86, and there should be a file kconfig. So arch x86, and then there's a file kconfig.debug. So now if you press F4, it lets you Alright, looks like they're being clever. So yeah, so what happens is the window manager's stolen the key, so the F4 has been stolen. So what I have to do is just click on F4 with the mouse. Now notice that if we go down the file, the first one we come to is, notice it says that early print K, it says if expert, then default is Y. What that means is that if it's expert, you can choose the setting, but if it's not, the setting is frozen out. So we get rid of if expert, and then the next one we need is line 352. So we have to go down a bit, and as you go down, watch this number here, because this will tell you what line you're on. So keep going until we get to 352. Or you can use page down. So we go to 352. Right, that's it. So that's about right. So here we are at the unwinder. So notice there was an awk, and then there was a frame pointer. So that's the awk one, and that's the frame pointer. So you think, okay, these are the two. So everything's fine, isn't it? It says, well, no, the sly kernel guys have hidden another one, which is guess unwinder. And notice here it says depends on expert. So what happens is, if you disable expert, they won't give you the option to use the guest unwinder, because those sly kernel developers want you to have a slow machine if you're not an expert, you know. But so why can't non-experts have fast machines? I've got no idea. So we save that with F2, and then just do, actually I don't think F10 will work. Yeah, I thought not. So if you just click F10 down here, and then F10 again, and then you exit out. And so now what we do is just run that configuration again, the menuconfig. And so now if we go back down to the kernel hacking and scroll down, now you'll see early print K, we can get rid of it. So celebration, get rid of that nonsense. And then finally, if we go to the kernel unwinder, we press in there and look what we got. And now here's the reason why we've gone to all that trouble to get rid of this guest unwinder. Because if I press Shift ? And read it, you notice that at the bottom it says, unlike the other unwinders, it has no runtime overhead, which is what we care about. So as you can see, the sly kernel developers were hiding the option for having no runtime overhead if you disable expert, which of course then enables debug, and you can't disable debug, so it's a bit annoying, isn't it? So that's it. So if we choose the guest unwinder, now we have a kernel which is pretty much running as close to the metal. Well, you might be able to get it slightly faster, but I think all the stuff we've gotten rid of is doing most of the job. So if you exit there and then make sure to save. And so now we're ready finally to do the compilation. And so this next command is just need to do a bit of preparation. Looks like he's doing a load more patches again. Right, so it's done all of that. So now we're finally ready to do the big boy. And now with this last command, you want to, depending on how many cores you have, so I've set this up to have 3 cores and 3 threads, so that's a total of 6. But what you find is that because of the way compilation works, it still won't use all 6. So usually you can add like an extra half to it to give you maximum use out of your CPU. So I'll just change that to 9. And just to show you what I mean, I'm just going to run htop. And so you see, and so this is from our host machine. And so you can see what's being used at the moment. So there's hardly anything. So if I now run this compile command, yeah, see now that's what you want. See now it's kicking in, and it's really using up that CPU because you want it to compile as fast as possible. You know, you don't want to be have to wait like an hour or 2 for a compilation to finish. Alright, so once this finishes, I'll be back. Okay, so the kernel's finally finished building. So now next thing we have to do is just go back into the previous directory, and so if we do a list there, we can see the kernels which have been built. And so we don't really need the debug one, even though it spent all that time building it for us. And so the kernels that we want to install, we just need to install the so basically what you want to do is you want to install the kernel first. Just trying to remember because I had a problem with this before. But anyway, so we don't want the debug one, so we just want the just the unsigned, so just U. So install that. Yeah, I forgot the sudo. I'll have to edit that as well. Right, and that's all you really need. I mean, I've got the headers, but you need the headers if you're going to be compiling. Yeah, I suppose you got all the NVIDIA users, they'll need that to compile their binary drivers or the binary only drivers, or if they've got the AMD FGL RX. Yeah, so a lot of people probably will need the kernel headers as well. Yeah, I had this error before. Oh yeah, so I think you need to install. Right, well the easy way around this is just seeing if. Oh, alright, let's do this. So I'm going to do it the way I did it before. So what you just want to install sysbench now. So this is what we're going to use to benchmark everything. Right, so that's where the broken part. Yeah, so now if we just type, there's probably a better way of doing this, but this is what worked last time. Okay, so now we can install sysbench. That should be that. Just see if the headers will install. Yes, so that seems fine. So, alright, so everything's sorted now. It's a bit weird the way you have to do that, but sometimes that happens. So now, before I just ran the benchmark straight away, but what I'm going to do, just to be fair, is just to reboot. So I'm just going to reboot it. Right, so that's booted up. So first thing to do is make sure we're still in the old kernel. So we can do get the version by typing uname-r. Yeah, so this is the 4.19.0-12, which is the original kernel that it came with. So now it's time to run the sysbench. So let's get those instructions. Right, so first one we're going to run is the CPU one. Now you notice for all of them I've timed it for 30 seconds just to save time basically, because it would just take too long otherwise. Okay, so that's the result for that. So anyway, alright, so let's go to the next one. So I'm going to run these 4 first in the original kernel that comes with the MX. Okay, so that's the next. So we do the 3rd one. This one is for file IO. Right, so that's the 3rd file IO one done. And so now the last one is threads. Now this one runs in record time, but I thought I'd leave it in anyway. Oh no, sorry, it was the 5th one that ran in record time, which was, I think, Utex, but it was too quick, so I just stuck with these 4 because these are the ones that sort of at least run for a reasonable amount of time. Right, so that's finished. So these are the 4 that are finished. So now I'm just going to see if I can save, because I was going to take screenshots of this, but I'm just seeing if it's possible to. Right, so I don't know what that actually is. Okay, so it's just a text output of. Right, okay, so that shows you the. So events per second. So, alright, so what we do is now I'm going to reboot, and then going to run that again, and then we'll just compare the outputs. Right, so now so what we do is you have to restart. And so now it's just restarting now. And so what you have to do is just move the cursor to stop it from booting. And so we want the first option, and then just press E to edit the entry. And now there's probably a better way of doing this, but this is just easier to do it this way, just to save time. So what we do is the kernel that I installed was 11. So we just change all the 12s to 11. And then basically just Control X to boot. So I don't want to press F10 in case it does something else. Yeah, see, it's complaining at the top about no Spectre, because they want you to have a nice slow kernel, isn't it? That's what the old developers want, because all they care about is what Microsoft cares about is security, is everything. No one cares about performance. Right, so now let's go again, and so we run. First, we check to see what kernel we've got. Right, so we've got the 419-11. And so we're just going to run each of those commands again. It should be stored, so we'll start with CPU. So basically this is running with my super cut down kernel, where it's just sliced all security out. The debugging has been sliced out. And that's many things. So security is gone, debugging is gone. And still no one can break into your machine, because obviously the standard Unix security still applies. That's the CPU. So we want the memory one next. Right, and so that's the memory. So the file IO. Right, and so then the last one is threads. Okay, so those are the 4 done. So now we just save that. Right, so let's see what's happened now. So basically this is the difference between, this is the old kernel, which is -12, and this is our new one. So let's see if what we did is of any use, or if it was just a waste of time. So let's see if we can, alright, yeah, I want it side by side. So let's see what we get. So the first one, so 10,000 threads, so CPU. So our old kernel did it in 4390, so 4390 events per second. New kernel 440, sorry, yeah. So, yeah, so there's a few more events per second. And 131, 132, so yeah, it's fractionally faster. So someone would say that, well, what's the point? You're going to recompile the kernel just to get a few points above the previous one. So, alright, so let's see now the next one, which is the memory. Right, so operation, Alright, total number of operations, 837, 54478. Total operations, 1048576000. Yeah, so that's higher. Now let's see. Right, now this is the important bit. See, we transferred 81 gigs, and it transferred at a rate of 2726 megabytes per second with the old kernel. New kernel kind of transferred the whole 102 gigs and transferred it at 5014 megabytes per second. So as you can see, my kernel with all the debug stuff cut out of it is just under twice as fast as the original kernel for memory transfer. So it doesn't affect the CPU, but for the actual memory transfer, the removing all of those things makes this much of a difference. And strangely enough, I actually had the difference was bigger before, but for some reason it's gone down. I don't know why. Maybe there's something, but anyway, doesn't matter. So what that shows you is that you can actually get you really do get a difference in improvement when you actually compile stuff out of the kernel. So let's see what file IO has to say. Right, so the file operations. Right, so writes per second 16897, 19480, so speed up again. F-syncs 21646, 20. So per second you're getting more writes and more F-syncs, and the throughput for write 264 megabytes per second on this one, and this one's 304 megabytes per second. So we can see there's an increase in the actual file writing to the disk as well. And so you can see that this kernel in 30 seconds managed to do this many more operations. So basically, if you want to have a higher memory bandwidth and faster writing to your disk, then yeah, it looks like you're going to have to be recompiling your kernel, unless you want to make do with all this slow stuff from the distro kernel instead. And so then the last one is the threads. I don't think this made much difference. Well, it looks like I was wrong again. So when it comes to multi-threading as well, so as you can see, the events 52,936 average. And with the new kernel, it's 89,000. So yeah, I think that's a bit of a boost, isn't it? So if you look at the number of events, it's 211,000. This one's 356,000. So you can plainly see, if you recompile your kernel and get rid of all the rubbish, your threading is going to be quicker, your disk access is going to be quicker, and your memory bandwidth is going to be higher. So this just completely confirms that yes, the days of thinking like a Windows user where you just believe whatever the manufacturer or the programmer tells you, those days are long gone. So now, if you actually want your system to run faster, then you're going to have to compile your own kernel and just rip out all of the annoying stuff that has been put in there by those programmers. Okay, hopefully you enjoyed this video. Yeah, it might have been a bit boring waiting through some of the bits, but at least at the end, we actually found out that yes, it was actually worth. Because if you're going to have this much more performance from recompiling your kernel, then yeah, for sure I'm going to do it. Because if I have to wait, see, I'm doing something with a lot of memory bandwidth and it takes a day to finish, then if you're telling me I'll recompile my kernel and it only takes 3/4 of a day, then I think, how much is that? 4/8. That's 6. So if I'm going to save 6 hours in a day, yes, I do believe I'm going to recompile my kernel seriously, or even for disk operations, or if you're doing threads as well. So there you have it. Now we know for sure why you should be recompiling your kernel.